In this video, we will try to solve a problem that was asked by a brother on Econ Maths Telegram channel. The question is like this. The demand for a monopolist's output is given by the function Q is equal to 6000 upon P plus 7 whole square. Okay. It has a constant marginal cost of $5 per unit, obviously. What price will it charge to maximize its profit? Okay, so what is the profit maximization condition? Profit maximization condition requires that means our profit maximization requires marginal revenue should be equal to marginal cost. Okay, this is one of the condition for the profit maximization. Okay, now let us see what we are being given here. We are being given a demand function Q is equal to this very thing. First we need to solve it for P, okay, to get the inverse demand function. Okay, so how can we solve it for P? If we transpose this term here, let me write it here. First we have Q is equal to 6000 upon P plus 7 whole square. If we transpose this here, this will become P plus 7 whole square is equal to uh, transposing this here, so this is 6000 upon Q. Okay, so let me use another color here. Now what will happen, this square when transposed to RHS, it will get reciprocated. Okay, so it is simply, if we have x to the power n is equal to y. Okay, let us say if we want to remove this exponent, if we transpose this here, the exponent gets reciprocated in the exponent. Okay, so this will become like this, x will be equal to y to the power 1 upon n. Okay, so this rule I am applying here. So this is p plus 7 will be equal to 6000 upon 1 upon 2, okay, divided by Q 1 upon 2. Okay, so I'm just if I took this square here, it will become like this, under root. Okay, and I have solved it here to save the space. So I hope you know this stuff very well. Now what we need to do, we need to solve for price. So P is equal to, transposing this 7 here, it will become minus 7, so I can write it like this, minus 7 plus 6000 can be written like this. Okay, I am just using 1 upon 2 as this notation here. Okay, I hope you know this basics well. So we have Q, let me write it here like this. Okay, now what is total revenue? Total revenue is simply price into quantity. That means to this function we have to multiply Q. That means minus 7 plus under root of 6000. Let me write it like this, Q to the power 1 upon 2. We don't need to change this in this notation. Okay, to this we multiply Q to get the total revenue. Okay, so multiplying this Q to each of these terms, that means total revenue will be equal to minus 7Q. Okay, plus we have under root of 6000 divided by Q to the power 1 upon 2 into Q. Okay, so further solving this will become minus 7Q plus under root of 6000, we have Q to the power 1 here into, if we transpose this numerator no, sorry, this denominator to numerator, the exponent sign gets changed, so we have Q to the power minus 1 upon 2. Simple maths. Okay, so if we have x to the power n, this can be written as sorry, if we have 1 upon x to the power n, this can be also written as x to the power minus n. Okay, so since bases are same, this is here 1 minus 1 upon 2, exponents can be added here. So this is 2 minus 1 is 1, so I get 1 upon 2 as the exponent here. So we are left with minus 7Q plus 6000. In bases are same, we subtract the exponents here, obviously we add it here. So let me write it here. So we have Q to the power 1 upon 2. This is our total revenue. What is marginal revenue? Marginal revenue is simply the derivative of total revenue with respect to quantity, that is dq. So we need to differentiate this area function with respect to q. Derivative of q is 1 by power function rule. So we are left with minus 7. Okay, so in this term, the derivative of q to the power 1 upon 2, if we take derivative, so this 1 upon 2 will become coefficient. We have q to the power 1 upon 2, and this exponent is subtracted by 1s. This becomes 1 upon 2. Q to the power 1 minus 2 is minus 1 upon 2. So I can write like this. We have 6000. In place of this, the derivative of this very thing comes out to be this. So I can also write it like this, 1 upon 2 q to the power minus 1 upon 2. Okay, so let me write it here. It is actually minus 7 plus this very stuff. Okay, now what we need to do here, I will rub this out. So this is our marginal revenue, and we can just rearrange this. So we have minus 7 under root of 6000 will come out to be, I have calculated it, this comes out to be 77.5 upon 2. We have q to the power 1 upon 2. I can again write it like this, 1 upon q to the power 1 upon 2. Okay, now profit maximization condition requires marginal revenue should be equal to marginal cost. Okay, so this is our marginal revenue. Let me write it like this. So I will write it here. So profit maximization requires marginal revenue should be equal to marginal cost. What is our marginal cost? Marginal cost is being given is $5. This is our marginal revenue. So we have minus 7 plus 77.5 77.5 upon 2. When we solve this, will come out to be 38.75 into 1 upon q to the power 1 upon 2. Okay, should be equal to the marginal cost. The marginal cost is 5. Okay, now we will solve for q. First we will transpose this minus 7, it will become plus here. So 7 plus 5 is 12. So we have 38.75 upon q to the power 1 upon 2 is equal to 5 plus 7, this is 12. Okay, let me write it now here, 12 to save the space here. So we get this as 12. Now we can do one thing here. One thing which we can do here is, if I write it like this, we have multiplying, I can cross multiply this also. We have 12 q to the power 1 upon 2 is equal to 38.75. that means q to the power 1 upon 2 is equal to 38.75 upon 12. That comes out to be 3.2. so this is 3.2 q to the power 1 upon 2 comes out to be this. If we transpose this exponent, it will get reciprocated. So q is equal to 3.2 square, and this comes out to be 10.24. that means q is equal to 10.24. that is our equilibrium quantity or profit maximizing quantity. But we need to find out the profit maximizing price. Okay, so we just need to plug this very value of q is equal to 10.24 in our inverse demand function. What was our inverse demand function? This very function. Okay, so our price will be equal to p is equal to minus 7 plus under root of 6000. We have calculated this under root of 6000, that is 38.75. okay, divided by our q has come out to be 10.24. that is like this. If we write it like this, 10.24 under root. Okay, when we solve, this comes out to be p is equal to minus 7 plus 38.75, and this here we have seen this square root comes out to be 3.2. Okay, that means P is equal to -7 plus, when we divide 3.2 to 38.75, this comes out to be 12.1. That means our P price is equal to -7 plus 2, 12.1, will come out to be 5.1. So our profit maximizing level of price should be equal to 5.1. Okay, I hope I have explained it very well. If there are any mistakes in this video, you can comment, because I'm just a student of economics. In their capacity, there can be some mistakes. Okay, so if you like these videos, please share with your friends. That is only motivation for me to keep going on. I am making these videos free of cost for you people. I have no other intention, rather to make myself more useful for you people. Okay, thank you.